All right, today we're talking about a robot that is completely different. It doesn't just do tasks, it actually changes its own body to deal with whatever you throw at it. And I don't mean just bending its knees. I mean growing, shrinking, and adapting in ways that honestly feel like they're straight out of a movie. So yeah, let's dive in.
So let me just start with this question. What if a robot could really, truly adapt to its environment by changing its physical shape? Imagine a machine that could literally grow taller or shrink down on the spot to get past an obstacle.
Well, that's not a hypothetical. The robot we're looking at today can stretch its limbs to more than 3 times their original length. That's a 315% increase. Just think about what that means. A robot that can instantly reach something way up high or stretch across a dangerous gap.
But it's not just about getting bigger. It can also squish its body down, shrinking to just 36% of its full height. This lets it get into these super tight spaces that a normal humanoid robot just couldn't dream of fitting into. And here's the kicker. It does all of this while weighing only 4.5 kilograms. That's under 10 pounds. This incredibly lightweight is really the secret sauce that unlocks some of its most amazing abilities. So what is this incredible machine? It's called GrowHR. That stands for Growable Humanoid Robot, and it was developed by a team of researchers at the Southern University of Science and Technology.
And just so we're clear, this isn't some far-off sci-fi concept. This prototype was actually unveiled back in January 2026. It's a real, working, soft-bodied humanoid, which means it's built from flexible materials, and it's already completely changing what we thought robots were capable of.
Now, to really get why GrowHR is such a huge deal, we first have to understand the problem it was built to solve, and that's the fundamental problem with traditional rigid robots.
This slide pretty much says it all. You got 2 totally different ways of thinking here. On one side, you have your classic rigid robots. Sure, they're super powerful, they're precise, but they're also heavy, fragile, and honestly pretty dangerous for people to be around. That's why you always see them locked away in cages on factory floors. But on the other side, you have the idea of soft robotics, building machines that are lightweight, adaptable, and totally safe to work right alongside us.
So how in the world did they pull this off? Well, the secret is in its really clever hybrid design that mixes both soft and rigid parts.
Let's break it down, because it's actually pretty brilliant. First, you've got the body, which is basically a soft, inflatable skeleton. You pump air in, and it grows. Simple enough, right? Then you have the bones. These are carbon fiber guides and cables that give it structure so it doesn't just, flop all over the place. And finally, the brains, a bunch of little motors and servos that give it fine control over its joints.
So that's the real magic right there. It's this combination of soft, air-powered systems, that's the pneumatics part, for all that crazy shape-shifting, mixed with rigid parts on the inside for strength and control. It really is the best of both worlds. And because of this unique design, it can do some pretty incredible things. This isn't just a robot that gets bigger or smaller. It's a true all-terrain, multi-talented machine. I mean, check this out. It can walk on 2 legs like a person, or it can drop down to all 4s and crawl to move faster. Because it's so light and airtight, it can swim. And this is where it gets absolutely wild. It can even walk on top of the water. And if he straps some fans on it, it can even fly for short distances. But you know what? Maybe its most important talent is just being safe. The research paper actually describes it as intrinsically safe for users, the environment, and itself. Because it's made of soft materials and it's so light, if it bumps into something or someone, it's not a big deal at all. In fact, the team is so confident in its safety that they've shown videos of kids literally hugging and pushing the robot around with 0 risk of anyone getting hurt. I mean, you would never, ever see that with a big industrial robot. No way.
So what does this all mean for the real world? Well, the possibilities are just game-changing. Think about search and rescue. It could shrink down to get inside a collapsed building, then grow a limb to hand water to someone who's trapped. Or in a disaster zone, it could walk across a flooded street to deliver medicine. It could even be in our homes, providing safe and gentle help for people who need it.
Now, of course, GrowHR is still a prototype. There are definitely still challenges to figure out. But the way its creators see it, these aren't problems. They're just the next set of fun engineering puzzles they get to solve. And what's really cool is that for every challenge right now, they've already got a potential solution in mind. Its flight is limited? Okay, maybe it could be tethered to a drone to stay in the air longer. It needs an external power source? Future versions could have built-in pumps. And as AI gets better and better, controlling all its complex movements will get easier and more autonomous. So here's the big takeaway. GrowHR really represents a huge shift in how we think about robotics. It's about moving away from designing for just raw power and precision and moving towards building machines that are adaptable, resilient, and safe, kind of like living things.
And that just leaves us with this one last, really fascinating thought. As robots become this safe and this versatile, the question isn't if we're going to live alongside them anymore. The real question is, where are we going to invite them to go next?